Hello everyone. Today we are going to read lesson 2 Inside the Blue Planet. After studying different rocks, scientists managed to calculate the age of our planet. Apparently, the Earth started forming about 4.6 billion years ago. At first, the Earth was just a ball of hot bubbling liquid rocks. These rocks were made from different materials. Some rocks were heavier than the others. After a while, the heavy rocks started to sink, moving towards the center of the earth, and the lighter rocks floated at the top of the heavier rocks, moving towards the earth's surface. This separation of rocks took millions of years. As the lightweight surface rocks were cooling down, they became harder. The average density of the earth is about 5.5 gram per cubic centimeter. Structure of the earth. According to scientific research and calculations, the distance between the surface of the earth and its center is about 6,400 kilometers. Up to a depth of 2,900 kilometers from the surface, the earth behaves like a solid, while at depths greater than that, it has liquid properties. Till now, no one has managed to drill down more than 15 kilometers because the temperature inside increases with increase in depth. The temperature at the center is estimated to be about 5,000 degrees Celsius. There are ways of finding out what is happening deep down in the earth without actually having to go there. Forces generated by earthquakes and volcanic eruptions bring the deeper lying rocks closer to the surface. These rocks are samples of materials that make up the insides of Earth. By studying these rocks, scientists have discovered that our planet is made up of 3 layers of different types of rocks and metals. These layers are crust, mantle, and core. The crust, lithosphere. The hard outermost surface of the earth is called the crust or the lithosphere. The earth's crust is like a skin that covers the earth. There are 2 different types of crust. Thin oceanic crust that underlies the ocean basins and thicker continental crust that underlies the continents. These 2 different types of crust are made up of different types of rocks. The continental crust, about 35 km thick, is made up of silica Si and aluminium Al, and so it is called Cl. The oceanic crust, about 5 km thick, is made up of silica Si and magnesium Ma, and so it is called Sima. The average density of the crust is about 3.0 gram per cubic centimeter. The crust is made up of tectonic plates which are in constant motion. Earthquakes and volcanoes are most likely to occur at plate boundaries. The Earth's outer crust is covered with soil. Soil is a complex mixture of rotting plants, animals, and rocks. Soil is a very important part of the Earth's biosphere. The mantle mesosphere. A layer that lies directly under the crust is called the mantle. It has a thickness of 2,900 km. It is the thickest layer and is mostly made of hot molten rocks magma. It lies between the crust and the core. The average density ranges between 3.5 gram to 5.5 gram per cubic centimeter. It is made up of dense and heavy materials, that is iron and magnesium. The mantle temperature is very high, 870 degrees Celsius to 2200 degrees Celsius. The core barosphere. The core lies below the mantle and is the innermost layer of the earth. Because the deepest layers have the highest temperatures, the earth's core is the hottest part. The earth's core temperature varies from 2200 degrees Celsius to 5000 degrees Celsius. It is also called barosphere. Scientists believe that the core is liquid on the outside and solid on the inside and is made mostly of metals like iron and nickel. Therefore, it is also called knife. Ni stands for nickel and Fe stands for iron. The average density ranges between 5.0 gram and 13.0 gram per cubic centimeter. Rocks and minerals. The Earth's crust has two main components which are referred to as Earth's materials. These materials include minerals and rocks. It is the combination of these materials that makes life on Earth possible. Minerals. Let's start with minerals and look at them in more detail. Minerals are naturally occurring substances that have a definite chemical composition. Minerals are referred to as naturally occurring because they are formed through natural geological processes. Over 4,500 different minerals have been identified on Earth. Each has a unique combination of physical structure and chemical composition. Salt is an example of a mineral. If you look closely at a grain of salt, you will see that it is a solid that has a specific shape and pattern. Coal, gold, and petroleum are other examples of minerals. Rocks. Now that we know what minerals are, we can discuss rocks. Rocks are defined as naturally formed aggregates of minerals or mineral-like substances which do not have a definite chemical composition. Rocks can be made up of one type of mineral, several minerals, or no minerals at all. A rock in which a certain mineral is found in large proportion is called the ore of that mineral. Mining is usually done in ore-rich areas. Limestone is a rock that is comprised of the mineral calcite. Granite is a rock that is comprised of several different minerals including quartz, biotite, and potassium. Coal is an example of a rock that is not comprised of any minerals but instead is made of decomposed organic matter. Rocks have different characteristics with their composition, color, texture, etc. Rocks are often classified by how they are formed. The three types of rocks are sedimentary, igneous, and metamorphic. Sedimentary rocks. Sedimentary rocks are formed from sediments that have settled at the bottom of a lake, sea, or ocean and have been compressed over millions of years. The sediments come from eroded rocks carried there by rivers or ice and from the skeletons of sea creatures. The word sedimentary has been derived from the Latin word sedimentum, which means settle down. They also contain remains of plants and animals called fossils. Examples of sedimentary rocks include sandstone, limestone, chalk, coal, clay, gypsum, rock salt, etc. Properties of sedimentary rocks. These rocks are not as hard as igneous rocks. They have horizontal layers arranged one above the other. These rocks are usually formed underwater and bear marks of waves and mud cracks. They contain fossilized remains of plants and animals between the layers. Igneous rocks. The inside of the earth is so hot that it melts rocks. Molten liquid rock forms when rocks melt. The molten rock is called magma. When the magma cools and solidifies, a type of rock called igneous rock forms. The word igneous has been derived from the Latin word ignis, which means fire. These rocks were the first to be formed and hence are also called primary rocks. The upper section of the Earth's crust is made up of around 95% igneous rock. There are over 700 different types of igneous rocks. They are also known as fire rocks. Types of igneous rocks. Igneous rocks are of two basic types. Intrusive igneous rocks are those rocks which cool down below the surface of the earth. Since cooling below the earth's surface is slow, the crystals formed are larger in size. Examples: granite and dolerite. Extrusive igneous rocks are those rocks which cool down on or above the surface of the earth. These are also called volcanic rocks. As cooling is much faster on Earth's surface, these rocks are fine-grained. Examples: basalt and pumice. The Deccan Plateau of India is made up of basalt rocks. Generally, the longer the cooling time, the larger the mineral crystals can grow. Liquid rock that reaches the surface cools very quickly. As a result of this immediate cooling, the crystals produced are extremely small. All of the world's sea floors are produced in this manner of rapid cooling. Properties of igneous rocks. Igneous rocks are hard and dense. They do not occur in distinct layers on beds. These rocks do not contain remains of plants or animals. Water does not percolate through them. Precious minerals such as iron, gold, silver, and aluminium are found in these rocks. Metamorphic rocks. They are formed when an existing rock, sedimentary or igneous rock, changes due to the immense heat and pressure inside the earth. These changes can affect the color, hardness, texture, and even the mineral composition of these rocks. They are usually resistant to weathering and erosion and are therefore very hard wearing. The word metamorphic has been derived from the Greek word metamorphos, which means change of form. Examples of metamorphic rocks include marble, which originates from limestone, slate, which originates from shale, schist, formed from sandstone or shell sedimentary rocks, gneiss, formed from granite, and so on. Gems are usually found in these rocks. Properties of metamorphic rocks. These are the hardest rocks having a high specific gravity. These rocks contain no empty spaces between them. After undergoing changes, these rocks remain in their physical and chemical state for an infinite period of time. Importance of rocks and minerals. Can you imagine a world without rocks? If there were no rocks, there would be no food, toothpaste, pencils, silverware, makeup, fertilizers, and so much more. If there were no rocks, we wouldn't have soil for plants and thus food. Soil is made mostly of rock particles and minerals. Rocks are used in building houses, schools, libraries, hospitals, offices, and shops. Minerals find wide use in buildings and other products. Iron as steel in the framework of large buildings. Clay in bricks and roofing tiles. Shale and gypsum in cement. Silica sand in window glass. Copper for plumbing and wiring. Clays for bathroom fixtures and fittings and tiles. Paint may include pigments derived from minerals. Bismuth is used for an upset stomach. Chemicals found in some sedimentary rocks are used to make fertilizers. Minerals like coal and petroleum are sources of energy. Rock cycle. Under certain conditions, any rock from one rock type can undergo changes and become an entirely new rock type. This is called the rock cycle. The origin of any particular rock can be determined by careful examination of its texture, composition, and internal structure, features that form the basis of rock identification and classification. The concept of the rock cycle is attributed to James Hutton (1726 to 1797), the 18th century founder of modern geology. The main idea is that rocks are continually changing from one type to another and back again as forces inside the earth bring them closer to the surface, where they are weathered, eroded, and compacted, and forces on the earth sink them back down, where they are heated, pressed, and melted. So the elements that make up rocks are never created or destroyed. Instead, they are constantly being recycled. The rock cycle helps us to see that the earth is like a giant rock recycling machine. Let's trace a possible rock cycle for newly formed igneous rocks. Igneous rocks are formed from magma. Magma cools and solidifies into rock. When igneous rocks are exposed on the surface, time and weather break the rock down into smaller and smaller pieces. This process is called weathering and erosion. Wind and water carry the smaller pieces of igneous rock into piles called sediment beds. Over time, the sediment beds get buried and pieces of rock become cemented together to form a new type of rock called a sedimentary rock. If this newly formed sedimentary rock is subjected to intense heat and pressure, it changes into metamorphic rock. The sedimentary and metamorphic rocks are buried again and melt to form magma. This magma again cools down and forms igneous rocks. So this was the reading of our lesson 2, Inside the Blue Planet. If you have any doubt or query, you can ask me in the comment section below. Also, you can find the links to other lessons in the description box below. Thank you everyone.